The winter is coming, and I needed a frost guard for my greenhouse, so I built one. Okay, I love Sean Ben, but I cannot really imitate him. So what this thing does, it keeps the greenhouse above the freezing point with a simple microcontroller and a relay switch that turns on the heater when the temperature falls below a set point. In this video I will explain how I built it. It took me a few hours, and if you follow all the steps, you can build one for yourself. For the case I used an old radio controlled switch that can fit perfectly the electronics I need for this project, which are Arduino Nano 3.0 and a relay switch. I also needed a temperature sensor and a resistor of 4.7 kilo ohms. This is the heater I'm using, and the 5-volt adapter for powering up the Arduino. The tools I used were hot glue gun, soldering iron, a multimeter, pliers, and a carving tool. I cut the case open, removed the circuit, and cut the red wires. To build my own simple circuit, I used a breadboard and some jumper wires. To connect the relay, I'm using the pins 5 volts, D6, and ground. These are easy to locate when you flip around the board and see the markings on the other side. I got these parts from dx.com for a few bucks. Normally open means the power flows through when the relay is turned on. For the temp sensor I'm using 3.3 volts, ground, and D4. And on the breadboard I had to connect the 4.7 kilo ohm resistor between the 3.3 volts and the D4 wires. I was able to fit the electronics in the case, but on the other side of the Arduino I had to cut these pins off. Once I got it working, I replaced the jumper wires with this extra cable I had laying around. Next I soldered the temperature sensor to Arduino to make it more permanent. The last thing was to solder the resistor between the power and data wire by first peeling the wires open with a knife and testing after with a multimeter that it still works. And this is how it looks all put together. On this clip I'm testing that the temperature sensor works with my fingers. When it reaches a certain temperature, the relay switch turns off. I know, it's almost like magic. Now I'm confident that it works, and I glue everything together with the hot glue gun. And when I turn it on, it looks pretty cool in the dark. And here you see a close-up of the temperature sensor that is sticking out from the bottom of the case. And finally it's time to connect it to the computer. To program the microcontroller, I'm using the Arduino IDE software. And for this program I need the wire library and the Dallas temperature library. You'll find the links in the description. To upload, I click on the second button on the top row. Lo and behold, I got an error message. To fix it, I change from the tools the port to COM3. Other things to check is the right processor and the right board. Next I open the serial monitor from the tools to see the actual reading from the temperature sensor printed on the screen. And now I was ready to set it up. So this is how the contraption finally looks like. You can see that I have connected the Frost Guard and the 5-volt power supply to an extension cord, and there's the USB cable going into the adapter, and the Frost Guard itself is connected to the heater. And now I only need freezing temperatures. So I set the camera to record, and I was picking up my laptop when the automation kicked in. Very beautiful, isn't it? So having a heater on automation is obviously a fire hazard. Please be careful when you install one, and also remember that you're working with the mains electricity to power grid. So if you're not comfortable with that, leave it to someone more experienced. Now as the heater is heating up the greenhouse, the temperature will hit the threshold and the relay will shut down the heater. Again, when the temperature drops, the heater is turned on again. And there's a delay in the program for 1 minute that allows the heater to stay on at least for 1 minute before it takes the next temperature reading. That will avoid the situation of the heater going on and off rapidly. Doesn't it look nice from the outside? I did a perfect job, didn't I? Well, that's what I thought the first night it was working. But the next day, it didn't turn off. So I went in with my laptop, plugged it in, and checked the serial monitor to get the reading of the temperature sensor. And I got 18 degrees Celsius. The actual temperature was much lower.
What?
I don't know how that's possible, so I removed my beautiful device from the socket and went inside to investigate. First thing I did was to drill a bigger hole on the top of the case to make sure it doesn't heat up. And then I used a very simple program to check if the relay is working or not. So the program simply turns on the relay for 5 seconds and turns it off for 5 seconds. And it seemed to work fine. So I re-uploaded the Frost Guard program and set it up again in the greenhouse. And now it's working perfectly. The current setting is on 3 degrees Celsius, and it's easy to change by simply connecting the computer to the Arduino and changing 2 lines on the code and re-uploading it to the microcontroller. The drawback of this design is that it's very hard to open if there's anything broken inside, but otherwise it seems to be working fine. So thank you for watching, and if you have any questions about the Frost Guard or how to build one, leave a comment below and I'll do my best to answer your question.